Welcome to AP Physics Podcast. This is question 15 from chapter 13. We have Io, which is a satellite of Jupiter, which has an orbital period of 1.77 days and an orbital radius of 4.2 times 10 to the 5th kilometers. We're finding the mass of Jupiter. Well, if we draw just a little diagram, here's Io, here's Jupiter. Jupiter is very, very large compared to the mass of Io. Io is in orbit around it, in some sort of elliptical orbit. So we can use Kepler's third law here, which says that the t squared over r cubed of some planet is equal to some constant k, and that is equal to, according to Isaac Newton, 4 pi squared over g times the mass of whatever we're going around. So our t needs to be in seconds, and our radius needs to be in meters. So when you do that, we're solving for the mass of our planet. We end up solving this equation that mass is equal to 4 pi squared r cubed over t squared times g. And if we start plugging everything in, 4 pi squared, our r is going to be 4.22 times 10 to the 8th meters. And we're going to divide it by 1.77 days times 86,400 seconds in a day. We might as well just write it like that. 1.77 times 86,400. And we're squaring that. And I forgot that we were cubing this, and we're multiplying it by g down here. We end up with a mass of Jupiter of approximately 1.90 times 10 to the 27th kilograms. Now it's worth mentioning real quick that this equation up here will only work for our little m, our orbiting body, much less than our massive body. So it works well here because Io's mass is much less than Jupiter. We're talking, has to be at least a couple orders of magnitude. This is AP Physics Podcast, question 15 from chapter number 13.